Paper 2, here we go. Right, as normal, they usually start off with something to do with binary and hexadecimal. So let's just run through solving, converting numbers, binary to decimal. So let's have a look. Convert the binary number 110100 into decimal. Well, working backwards, 1, 2, there is a 4, 8, 16, 32, there is a 64, and there is 128. 4, 16, 64, 128, 4 plus 16 is 20, 20 plus 64 is 84, 84 plus 128, 212. 1 mark. Convert the binary number 1011111001 into hexadecimal. Now you could of course convert this into a decimal number, then convert that into hexadecimal, but the easiest thing to do is to remember that 4 binary digits, 1 nibble, is the same as 1 hexadecimal digit. So I'm just going to separate it into 2 halves, and we're going to convert each number separately. So 1011, 1, 2 and 8 makes 11. 1001 is 9. Obviously we can't write 11 hexadecimal. Remember, once you get past 9, A is 10, B is 11. So the answer is B9. State the largest decimal number that can be represented using 6 bits. Well, what you could do here, of course, is you could write down 6 ones. 1, 2, 3, 4, 5, 6. And work that out. 1 and 2 and 4 and 8 and 16 and 32, which is 63. Or you could say to yourself, the next one afterwards would be 64. So therefore, everything beforehand would add up to 63. Just be careful here. Sometimes they ask this question as in how many different numbers there are in 6 bits, and that would be 64. But the largest number is 63 because you go from 0 up to 63, 64 different numbers. Now the classic, they ask you to do a binary addition, and if it helps before you start, just write down for yourself that you know that 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 1 equals 1, 0, 1 plus 1 plus 1, that's 3, which is 1, 1. Keep those things in mind when you're doing this, and then everything should work out okay. 0 plus 0 plus 1 is 1, that's easy enough. 1 plus 1 plus 0, that's 2, which is 1, 0. So we can put down, as always, put down the 0, carry the 1. 1 plus 0 plus 0 plus 1, that's 2 again, which is 1, 0. So we put down the 0, carry the 1. 0 plus 0 plus 0 plus 1 is just 1. 1 plus 1 plus 0 is 2, which is 1, 0. So we put down the 0, carry the 1. Now 1 plus 0 plus 1 plus 1, 3, which is 1, 1. So we put down the 1, carry the 1. 0 plus 0 plus 0 plus 1 is 1. 0 plus 1 plus 0 is 1. If you're happy and think that you're fairly confident that you know what you're doing, fine, leave that. If you get some spare time at the end, come back, turn them into decimal numbers and make sure that they add up correctly. And we move on. Now, how do we multiply? So binary shifts are used to multiply. Apply a binary shift 3 places to the right on this bit pattern. So that means that the whole bit pattern moves 3 places to the right. So the 1, 1, 2, 3 goes to the end. 0, 1, so it's 1, 0, 1, 0, 1, moves to the end, and then we fill in at the beginning with zeros. Bang, 1 mark. The arithmetic effect of applying a left binary shift, so moving the number that way, so just the same as you would with a decimal number. Remember on your maths, when you move a decimal number to the left, it multiplies by 10. So with a binary number, when you move it to the left, it multiplies by 2 each time. So applying a left binary shift of 2 is to multiply that number by 4, because it moves once and that multiplies it by 2, and again multiplies it by 2 again, which is to multiply it by 4. State the arithmetic effect of applying a left binary shift of 4 to a binary number. Well, think about it. You move it once times by 2. Move it twice times by 2 again. 3 times by 2 again. 4 times by 2 again. So times 2 times 2 times 2 times 2 is the same as multiplying by 16. State the arithmetic effect of applying a left binary shift of 3 followed by a right binary shift of 5 to a binary number. Now if you want, you can do the whole thing and go back again, or you can say to yourself, right, if I move left 3 places and then I move right 5 places, that's the same as moving right 2 places. Okay, what's the effect of moving right by 2 places? Well, if moving left multiplies by 2, moving right divides by 2. So I've divided by 2 and then divided by 2 again, in which case I'm dividing by 4. And there we go. Okay, so that's done our binary and our hexadecimal stuff. Let's move on to logic tables and logic gates. Okay, so in this new specification, they've introduced the XOR gates. We know the AND, OR, and NOT gates, and we've also got to learn the XOR gate. So an XOR gate means that if the one or other input is 1, the output will be 1. Otherwise, the output is 0. So 0 and 0 gives you 0. 0 and 1, either 1, yeah, either 1 is 1, so that produces a 1. 1 or 0, either 1 is 1, yep. 1 XOR 1, so both of them are 1. So it's not that one of them is 1, which is the reason that you get a 1, so you get a 0. Now, a game uses 3 sensors. A red light in the game switches on if all of the following conditions are true. Sensor D is off, sensor L is on, sensor W is on. Complete the logic circuit for this game. You must use the correct symbols for the logic gates. Now, as soon as you see that sensor D has to be off to make it work, immediately you think, right, well, if that's got to be off to switch something on, then we're reversing. So in which case, we definitely are going to need to not. Not will reverse what sensor D is doing. Now it says that all of them have to work, so that means it has to be this and this and this. So the 3 things have to be on to make something go on. So we're obviously thinking now of AND gates. Now an AND gate can't take 3 inputs, so we're going to have to AND, so it has to work if both of those are on, and then it has to work if that is true and that one is off. So again, we have to take the output from that and it again, and then join that up to there. Okay, so if you see that 3 things have to work together, that means all of them have to AND together, which means that you have to AND 2 of them and AND that with the other one. Now we're moving into the sort of symbol logic now rather than diagram logic. So another circuit in the game will output true if any 2 sensors are activated, or if all 3 sensors are activated. This has been represented as the Boolean expression da 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 da. Now think about that. Let's look back at it and let's think. So if these two are activated, or these two are activated, oops, you can't see, let's try that again. So these two are activated, or these two are activated, or these two are activated, then it will work. So this one and this one, and this one and this one, and, or this one and this one. So if you think about it, we're anding two of them in each combination and saying it's one or the other or the other. Okay, let's look back at this now. So we're saying W and D, fine, or, which is plus, D and L, or, oh, hold on a second, that should say or, shouldn't it? So it must be the one where the three possible combinations are ORed with each other, which would be the one where, there you go, W and D, or D and L, or W and L, C. Okay. A green light in the game switches on if all the following conditions are true. Sensor D is off, sensor L is off, sensor W is on. Again, all of the following conditions are true, so it has to be this and this and this. And notice D off, L off. So again, remember, as soon as you see that something being off makes something else work, immediately we think that's got to be knotted. L has got to be knotted, W not. So we could write this as D knotted and L knotted, because it has to be off to make it work, and W. That's perfectly good. Or we could write it as, using the logic words, not D and not L and W, and that would be perfectly fine as well. Number 4. Describe. Right, we've been doing a lot of calculating and we've been doing a lot of stating. This is our first time that we've had to describe what is meant by the term system software and application software. Now we're getting 2 marks here, so 1 mark for each, so we don't have to go into too much detail, but we have to make it clear what makes these 2 kinds of software different for each other. So you can get a mark simply for saying that system software controls the hardware, or you could say system software makes the hardware available to the user. So anything like that about system software. The idea of system software is it's what makes it so that you can use the hardware without having to know what the hardware is doing. So basically we're talking about the operating system here. Application software, and all we have to do here is we have to say something like enables the user to complete tasks. Anything that gives the idea that it's the software that enables you to do tasks of some sort. So provides the user with the ability to do tasks, is used for different tasks. Anything of those will be fine. Right, we're moving on now to be more specific about the operating system itself. State. Now when you see state as the command word, don't forget you don't have to write a full sentence. So there's no point in sitting here and wasting your time writing one function of an operating system is, the second function of an, no, merely writing 4 phrases is perfectly satisfactory. So if we put something like allocating time in the CPU to tasks, that would be one. Controlling input and output peripherals or devices, that would be fine, you can have that. If you just wrote system security, that would be good. Memory management, so allocating particular areas in memory for devices, for your programs to allocate to be used. You could talk about sort of managing storage, that would get you a mark. So there you go, there are 5 for your 4. Any of those and any of the things that you've learned about the operating system would be fine. We haven't mentioned the user interface. And notice that it's quite acceptable for you to write just simple phrases to get the 4 marks here. Now, moving on to question 5, we're now getting to our first long answer question. So I'm not going to write out the full paragraph here, I'll leave that for you to do, but just to give you an idea of what will be expected here. An autonomous vehicle is controlled by a computer system, senses its environment and requires no input from a human driver. So we're talking about computer-driven cars, autonomous cars, like we're starting to see being experimented with now. Discuss the legal and ethical impacts. Legal and ethical impacts that need to be considered when replacing manual, human-driven vehicles with autonomous vehicles. So we're thinking about what effects will it have in the way we have to manage our lives because we've got these computer-driven devices. Well, let's think about what legal issues might well apply. So with legal issues, we're thinking about things like people's privacy, we're thinking about control, we're thinking about who's in charge, we're thinking about who's responsible and how they may be held responsible. With ethical impacts, we're starting to think about where people might have things stolen maybe. We might be thinking about whether people are able to do what they want when they want, or are other people taking control of their lives. So there are a couple of things we might think about here. When it comes to the legal impacts of this, let's think about it. If there's an accident, who's responsible? Because now it's not a human driver, isn't it? Also on the legal front, we're thinking about, well, if it's being controlled by a computer, how do we know what's being done with our data? Think about data protection. The vehicle obviously knows where it is all the time, so the vehicle knows where you are all the time. So how's that data being used? And ethical issues. Who's in control of the car? So what would happen if someone else was able to take control of the car? What about the fact that we need to think about how our data is being used by other people? So someone else is in control of me when I'm in this car, and how do I know that I can trust the person who's in control? So now what we need to do is we need to turn that into at least 2 good paragraphs, preferably 3, but 2 will be good, and covering both of these issues. So with the legal issue, you might want to think about something like introducing the idea about ideas about fault in an accident. So you might want to think about that. Then you need to think about explaining that, because you might want to say the algorithm controls the vehicle. So who is to blame? If anyone. which means new laws are needed. So turn that into a paragraph and you won't go far wrong. So there's a legal aspect to it. Let's think about an ethical one, maybe about your data being stolen. So you can say something like concern over privacy of data. Why is that a concern? Because the vehicle could be data could be used to track you. Which might lead to stalking. And that would discourage people from using cars like that. Using autonomous vehicles. And again, build that up into several sentences in a paragraph, and you've got two well thought out, well described descriptions of how these kind of vehicles aren't just cool because they're doing stuff that's quite sophisticated, but they do change the way we have to work in our normal lives. Any other things like the car being hacked and therefore being controlled by people you wouldn't want it to be, what happens if the car goes wrong, the sort of data protection law, any of these things that you can bring in are all good, but remember you must work through saying what the problem is, why it's a problem, and how it will lead to an impact, and put that in about 2 or 3 sentences in each paragraph to get the full 6 marks. Well, we'll leave that there as the end of part 1 now, and in the second half we'll move on to question 6.